Hey, it's Jim, and this is level 1 of the CFA program, topic on quantitative methods, and the learning module on Introduction to Big Data Techniques. Let me just quickly remind you that this is the last learning module in quantitative methods, and we've spent some really good time discussing things like inference and estimation, hypothesis testing, linear regression, correlation analysis. What we relied on back then in those discussions was the use of data that was probably structured. I'm sure I said this to you in the previous learning modules. Just think of a big old Excel spreadsheet that has independent variables and dependent variables in a structured format. And we ran some simple linear regression, and once we get to level 2, we'll do multiple linear regression, and we'll do time series, and we'll do ARIMA models and GARCH models. I mean, we'll really expand on that. But I want you to think about the following possibility. Suppose that you have this Excel spreadsheet with structured data, but then you add some data that includes things like text messages, Instagram videos or photos, YouTube shorts, TikTok, whatever TikTok is, I don't know what that is. How about even what happens when you open up your refrigerator? These smart refrigerators now, they keep track of things like what's in there and how many times you pull it out and how much you throw away. I would love to have seen some kind of data on my father's refrigerator. If he were to have had a smart refrigerator when he was alive, he would go to the brewer's outlet about once every 2 weeks and get 2 cases of Budweiser. And he would drink those, but my dad was one of those really cool beer drinkers. He did not like his beer to be freezing cold. He liked it to be just a little bit cold. And so clearly imagine this Excel spreadsheet with a whole bunch of data on my dad's consumption habits with the temperature and the number of beers and the number of guests in the house, etc., etc. I mean, it becomes too big for an Excel spreadsheet. So what do? We need big data techniques. So that's what this learning module is all about. It's interesting how the Institute has kind of evolved in their discussions and their presentation of this big data topic over the last couple of years. I'm guessing that after you guys pass level 1, there'll be more details in level 2 and in level 3 as you go forward. Just 3 LOSs here. Fintech, we'll do that pretty quickly. Big data, artificial intelligence, and machine learning. And then how does this relate to investment management? Now, from my perspective, this is really the most important of those 3 LOSs, because what we haven't learned yet in level 1, but which will be emphasized in level 2 and especially in level 3, is the importance of the investment policy statement, excuse me, which is essentially a binding document between the portfolio manager and his or her client that outlines all sorts of relevant information. So the question then becomes, how do we use this big data, right? This huge data set and quantitative methods, although we're calling it now data science, to help us make better financial decisions for our client. Now, I will also pause and say to you, you guys know this from the very beginning of level 1 here, I'm big on going to the end of each learning module and looking at those end of module questions. There are only 3 of them at the end of each one of these. There's one on the characteristics of big data, there's one on machine learning, and there's one on text analytics. So what I want you to do when we're done this recording is I want you to immediately go to the end of the learning module, and I want you to answer those questions. I bet you can do it in a minute. We'll cover those 3 answers here. All right, so let's start with Fintech. So the first sentence in this section here says something like, hey, Fintech is this term that describes the link or the marriage or the union of finance and technology. What do we have in bolded there? Technological innovation. So what does that mean? That means that we have all of these new sources of data. I mean, go back to the old days. And when I say old days, how about 1993? In 1993, we didn't have the internet, we didn't have smartphones, we didn't have refrigerators that could tell the temperature of my father's beer. We didn't have any of that stuff. So what did we have to do? We had to go out and work really, really hard to collect all this data, decide what's relevant, decide what's irrelevant. Now we're just completely inundated with information and data and noise. Oh my gosh, we're going to talk at great lengths once we get through level 3 about this dude named Fisher Black. And he was part of the trio who came up with the Black-Scholes-Merton option pricing model. And he wrote an academic journal article that only had one word in it, and it was called Noise. And for those of you who have ever seen a Journal of Finance or a Journal of Financial Economics article, there are sentences in the title, blah, 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 all these kinds of things. Fisher Black, he was a minimalist, and so noise. All right, so it's our job to try to figure out what's relevant and what is noise. And if we have this massive amount of data, we're calling it big data, we've got to sift through this massive amount and try to figure out what is noise and what is relevant so that we can make better decisions. And so we're going to do this based on our own intuition, all the stuff that we learn in levels 1, 2, and 3. We're going to use regression analysis. We're going to use these other quantitative techniques that we'll learn in level 2 especially, and even some in level 3. And then we're going to learn these Fintech tools, and we're going to start that here in this learning module. Look at the bottom bullet points there. Analysis of large data sets, analytical tools. All right, what is big data? Big data is exactly what it suggests. It is huge data. I don't know what other word that we could have come up with other than big. So it's nice and short and right to the point. So there's traditional data sources, which I described, and then there are non-traditional sources as well. Social media, sensor networks, electronic devices. I can't help but read this learning module and go back to one of my favorite series of movies. Are you guys old enough to ever watch the Jason Bourne movies? Every time Jason Bourne goes down the street, somebody's watching him with a camera. Sounds an awful lot like George Orwell to me. All right, here's that first question at the end of this learning module. Characteristics of big data. So we'll talk about, here, let me do this quickly here. You ready? So there are 4 V's. So we'll do volume. So what does that mean? You can't even count, right? You can't even count how big this volume is. Incomprehensible proportions. Velocity, this means speed of data. What we'll find out when we continue our discussions in level 2 and level 3 is the speed with which an order gets placed, somewhere in the United States, how that order moves to maybe the Chicago Mercantile Exchange or to the New York Stock Exchange or the NASDAQ Exchange. And that speed is measured in milliseconds or microseconds. And so the important point here, and this is one of the choices in this question at the end of the learning module, is that real-time or near real-time data. Variety, this is what I was saying earlier. It could be structured or semi-structured or unstructured. So there's all sorts of crazy data that's out there. We need to figure out what is noise. Let me give you just a quick example. Suppose I'm Milton Hershey and I wake up one morning and I say, you know what? I'm going to go out to my garden and I'm going to chop some broccoli out there and I'm going to have some broccoli for lunch. All right, so I do all that. I steam it, maybe I put some seasoning on it and some cheese. And I have a great lunch. I take a picture of it and I put it on my social media and it's out there. And here I am, Milton Hershey. Now, of course, Milton Hershey's been gone for quite some time, but suppose that I'm Milton Hershey and I put this on my social media and then some people start thinking, wait a minute, is Milton going to start incorporating broccoli into his chocolate or his licorice or his cereal? And so then maybe I take a picture of my broccoli field, and then I take a picture of someone eating broccoli at one of my plants, and then oh my gosh, so is this data? Is it noise? Is it structured? Is it semi? I don't even know what it is, but that's what this big data, artificial intelligence, and machine learning is going to help us try to process this and figure out what's noise and what's relevant. course, I'll have to go out and give you another Seinfeld example. Do you remember when Newman got broccoli when he ordered Kenny Rogers chicken, and Jerry said to him, "Newman, you wouldn't eat broccoli if it were dipped in chocolate." I have no idea what that means for any of this stuff here, but hey, it's my job to keep you entertained over the course of 30 minutes or so. All right, veracity. Now, this is going to be super important. This is a great exam question. I'm going to alert you to a future learning module on financial statement analysis. We're going to have a conversation about the quality of the financial statements that are published by corporations. Oh my gosh. So as you can imagine, if we have accurate and fair data published by corporations, then we can make good decisions. Well, the same thing applies here to big data. So make certain, I don't know how we do it, but somehow we're going to have to make certain about the quality and the accuracy of the data. Sometimes we can do this with our own experience and our own human judgment, but a lot of times we're going to have to rely on artificial intelligence or machine learning to say, you know what, there's no way that Milton Hershey is going to have a chocolate flavored broccoli, or a broccoli, I don't know, broccoli stems covered in chocolate. I don't know, it sounds kind of gross to me, but who knows what people will eat. All right, structured data, just think Excel spreadsheet, high degree of organization. Unstructured data cannot be presented in tabular form, and then you can have some combination of the two. This is a really good exam question, and let me just alert you to this. I mean, look, there's three choices here: structured, unstructured, semi-structured, and so this lends itself tremendously for a potential exam question where in the question stem you're given a bunch of data and the institute says, which one is it? Is it structured, unstructured, or is it semi-structured? So just think Excel spreadsheet, think Milton Hershey with a picture of broccoli. Yeah, sources of big data. If this shows up on the exam, then you need to check the correct answer, because this will not be too difficult. Financial markets, businesses, governments, individuals, sensors. There's the traffic data, satellite imagery, Internet of Things, CCT cameras. There's the whole Jason Bourne thing. There's the home appliances with my dad and his Budweiser. By the way, for those of you who are concerned about my father and my upbringing, my father, he always limited himself to just 2 or 3 beers a night, so that was okay. Top sources of alternative data generated by people. So this would be exactly like my dad just reaching in and getting a Budweiser out. But it could also be you or I just visiting a web page. And then I've come across this thing on my phone. Recently, my wife bought me a new phone. I had an 8-year-old phone, and so I came across these YouTube shorts. I think that's what they're called. And you just flick up, and my gosh, it's mind-boggling. So how many times do I flick up? How many times can I watch a Seinfeld scene or a James Bond scene? And some of these things are interesting. Most of them are not. But of course, this is interesting data, because if I'm going and I'm watching Budweiser, and then I watch another one, Budweiser, then sooner or later, somewhere on my phone, there's going to be a coupon that says, hey, Jim, go to a Brewer's Outlet and get $5 off a case of Budweiser. Okay, so data generated by people, data generated by commercial operations. I can't even imagine how many times I've gotten onto my bank's webpage and I've transferred money from my account into any of my children's accounts out there. So they keep track of that. And so sooner or later, someone's going to send a note to one of my children and say, hey, you know what? Your dad's giving you all this money. Why don't you go spend it over there? And then data produced by the sensors, satellites, and smartphones and webcams. All right, so what are challenges? The challenges is that we cannot get our arms and wrap ourselves around this. And if we do, then maybe we can't squeeze hard enough to get out all of the noise. So all these challenges here. So what are they? Selection bias, missing data, data outliers. What do you do when you got that outlier way out there? Well, we'll learn all about that in level 2. The volume of the data set used may be insufficient. This is a challenge. You think you have the big data, but it's all this noise, and when you squeeze out the noise, you have 8 observations. That's not good enough. And then appropriateness. Yeah, so difficult to source, clean and organized before performing any analysis. Yes, mostly unstructured data. So that makes perfect sense. So how do we do this? Artificial intelligence and machine learning. All right, so what are we doing here with artificial intelligence? We're trying to fake out everybody to think that we're looking like a human. So I use this example all the time in class. Those of you who've never seen it, go back to 1984, watch the Arnold Schwarzenegger Terminator movie. This is a perfect example of artificial intelligence. Yes, these computer systems, these machines exhibit cognitive and decision-making abilities. Arnold Schwarzenegger made tons and tons of decisions when he was sent from the future back to 1984, and he was supposed to terminate one of his enemies. Now, I'll give you just another stupid example here. Take the form of if-then statements. When I was back in college, now, this goes way, way back to the early 1980s, I had to take a class on computer programming, and I had to write these if-then statements. And we had to type them out and hit a button, and they were on these little cards, these little index cards. And we had to feed the index cards into, I guess it was an IBM mainframe computer. And to get something to go like, okay, when I walk to a door, I want to open the door, and then I want to walk through. How do you program the computer? I mean, there was a stack of index cards this big, if-then statements. I hated it. Plus, I wasn't any good at it, and I wasn't really interested in it. And so, as I'm guessing, that did not translate into a very high grade for me. Now, machine learning is the use of computer-based methods to draw knowledge from these massive amounts of data. So we have this data. What we need to do is we need to divide this data into a couple of different subsets. And that's essentially what we're doing here. So we have a training data set. So imagine we have massive amounts of data on publicly held companies. We have things like cash flow per share. We have things like the IQ of each board member. I don't know how we would get that, but maybe we get it. We have how many bottles of Budweiser they have in their refrigerator. We have all this data set. So we put it into a training data set, and we throw the algorithm at it. We say, okay, Mr. or Mrs. Computer, go ahead and look at this data set. Try to find some relationships between and among the variables that are thrown into the model. So what the training data set does is the model, this machine learning, it works and works and works and works somehow. You see I'm doing this, I have no idea what it does inside of a machine, but it works and works and works, and it comes out with a model. So then this model, whatever that model looks like, now remember when we did the simple linear regression, we had y equals a plus bx. So imagine a model that's 100 times more complex than that thing, but it's going to figure out relationships between and among variables. So then we have this validation data set. So we've kept some over here secretly, right? And then we just throw the data into the model and say, okay, how good was your training model? And then use this extra information to figure something else out. So you get the sense that it's learning. So it trains, and then we validate it, and it learns. It says, oh, well, here, I did this, but I should have done that. I did this, I should have done that. So after a while, we get this best performing model. And then after a while, we throw in a test data set. So we kept another section of the data set private, and we've said, all right, now let's go ahead and test it. So after training and after validating, we have a model, and we think it works really well. Then we test it with data, and we figure out how good it is. So we can do supervised learning, where you can say, I want some desired outputs. We can say something like, oh, I want to take, what was I saying earlier? Cash flow per share, IQ of the executives, bottles of beer, dividend yields, number of years that the CEO has worked for the company. So we have that structured data set, and we have unstructured data set, right? Whatever that is. And then we say, you know what? I want you to say Yes or no? Should I invest in this company or not? A desired output. Well, there we have at the bottom, performance of a stock up or down. So that makes sense. Unsupervised learning, what we do is we just throw all this stuff at the computer and say, you figure it out. And so what the algorithm does is it goes and it finds relationships. And we're going to learn extensively in level 2 and level 3 about clustering. And there are all different sorts of ways that you can cluster. You can do it according to standard deviation. You can do it according to some other kind of measure of distance. And we'll see all that as we go through the program. But you have a cluster here and a cluster here, and maybe mini clusters and maybe some noise all the way out here. So what happens then is that the computers learn from this clustering. And so in the end, we have a group over here, a cluster, that has, well, what was I saying earlier? That has cash flow per share within this range. It has board of director IQ within this range. It has, and so now we can try to figure out what's important about each of those clusters. How can we use those clusters to better serve our clients? Deep learning, these are neural networks. Deep learning, I'm not quite sure what that means. I always think of deep space. When you go into deep space, the scientists, they keep telling us that, when you go way, way over there, it's like, 100 million light years away. I have no idea what that means. But this neural network, this is important. Multi-stage, non-linear data processing. I'm going to go back to one of those great movies. Most of you probably weren't even alive. Back in, what year was it? 1993. That first dinosaur movie came out. I had read the book by Michael Crichton. I read it in 2 days. I was fascinated by it. But do you remember the one scientist? He talks about chaos theory. And that was the first time I had ever heard about chaos theory. I've read a bunch about it since then. And so this is a little bit what's going on. Chaos, from a seemingly chaotic environment, this deep neural network can find relationships in there. And so maybe what appears to be a chaotic floor of the New York Stock Exchange is really a system of patterns that are undetectable to the human eye, or at least my brain. Who knows what's going on upstairs? Yeah, so we can do this supervised or unsupervised. We try to recognize patterns. All right, how about data processing methods here? So data capture, that's exactly what it means. Data curation. So what we're trying to do is make sure quality and accuracy. This goes back to the veracity earlier. Storage, where are we going to store all this stuff? How are we going to search inside of the databases? And then how are we going to transfer it? Do we want to transfer it really, really quickly, or do we want to transfer it really, really slowly? Yeah, we have all of these web pages, we have all of these text messages, we have all of these refrigerators. What do we have? There's a circle picture over there. What does this mean? How do we do this if we're going to visualize? And so this was that third question at the end of the learning module on text analysis. How do we do this? You have these texts. And so those of you who read the Wall Street Journal or the New York Times, you know that there are politicians out there who may or may not be guilty of some crime, but they're being indicted and they're being arrested for things. I'm not sure if they're guilty or not. Of course, the justice system will play out over time, but you have all this stuff out there, text messages, social media, videos. Oh my gosh. So how do we do this? So we try to throw it into a graphical representation. Yeah, here's that question on text analytics. So let me go ahead and just give you the answer there. Can be utilized in predictive analysis. Yeah, so this text is not just text messages, between people who like each other or who like to text, but just any kind of a text, any social media, any web page, and it can be voice-based as well. The cool thing about text analytics is that you can scan a filing with the SEC. And by the way, let me just remind you, although I'm not sure I said this to you, but you'll hear me say this as we go through level 2 and level 3 videos. When I was writing my dissertation, I spent tons of hours in the basement of our library going through as many little of those microfiche. You guys don't even know what those little microfiche things are, but I had to look under it. It was almost like a microscope. and hours and hours of stuff. But now I'm pretty sure I could do that in about 10 minutes. Text analytics. And then, excuse me, natural language processing. Yeah, decipher and analyze human language. I was just reading a book where there were two translators, and they were translating with two world leaders, and the two world leaders, they needed the translator, and now this is a fiction book, and so they conspired to do something, and the two translators, they were worried about their lives. So these translators' jobs was to make sure that they translated properly for their boss, and then make sure the other translator was an accurate translation, et cetera, et cetera. So that's what this thing does here. All right, we've covered just 3 of these, and I want you to go to those 3 questions at the end of this learning module. You ought to be able to answer them in a minute. All right, so I think we're moving on to the next topic. So have a great day. Thanks for watching, and good luck studying.